Okay, in this video we're going to review the concept of converting quadratic standard form to vertex form. So this function here is quadratic. It has the x squared in it. It's given in standard form, ax squared plus bx plus c. And vertex form looks like this. F of x equals a parentheses x minus h with the quantity squared plus k. H and k are the vertex of the function. So we don't need to know any fancy algebra like completing the square if we can just find the vertex of this function. We have a formula that helps us find the vertex of a quadratic function. X equals negative b over 2a. This will give us the x value of the vertex. And so negative b here is going to be negative 8 divided by 2a. A value is 1. If I simplify that, it's positive 8 over 2, which is 4. So now I know that the x value of the vertex is located at 4. In order to figure out the y value of the vertex, which is called k in our equation, I need to plug that 4 into the function and figure out what the output would be. So I'm evaluating f of 4 and figuring out that it's 4 squared minus 8 times 4 plus 10. 4 squared is 16. 16 minus 32 plus 10, that's negative 16 plus 10, so negative 6. So now I know that my vertex is located at negative 4, negative 6. Positive 4, negative 6. I can now plug that in to the vertex form of the quadratic function. So f of x equals, I'm going to leave a out of the picture for a second, put some space there for it. X minus h is going to look like x minus 4 because the minus is actually part of the formula. So if my h is positive, it's going to look like a minus 4 in here, squared, and then my k value is negative, so I can write that as minus 6. And you might think that you don't know a, but the nice thing about a is that the a value from standard form, which here is 1, is the same as the a value from vertex form. So there is a 1 in front. You don't necessarily need to show that. So to convert to standard, from standard to vertex form, you just need to find the vertex, that's h and k, and then keep the same a value as was given in standard form. The way this might look on an exam question, x squared minus 4x plus 5 is the function. First thing it asks us to do here is find the equation of the axis of symmetry of the graph of f. The axis of symmetry goes through the x value of the vertex. X value of vertex. So we have a formula for that. So to get the axis of symmetry, we use x equals negative b over 2a, which for this function is x equals negative 4 over 2 times 1. Negative 4 is positive 4, divided by 2 is 2. And so the equation of the axis of symmetry is x equals 2. It's important that because it's asking you for an equation, that we give our answer as an equation of a vertical line. So x equals 2. And then it says this function can also be expressed in the form x minus h squared plus k. That's vertex form. The a value is not even shown there because in both of these, the a value is 1, so they don't even show it. So they're asking us to then write down the value of h and find the value of k. H, we know, is the x coordinate from the vertex. So we already know that h is 2. We just found that out. And then find the value of k, we know that we just have to plug 2 back into the original function. So we'll be looking for f of 2, and it'll equal 2 squared minus 4 times 2 plus 5. So 2 squared is 4 minus 8 plus 5, 4 minus 8. It's a non-calculator question. These numbers are manageable. 4 minus 8 is negative 4, plus 5 is 1. And so the value of k is 1. It doesn't ask us to write the final function in vertex form, but if we did, it would be f of x equals x minus 2, quantity squared, plus 1. That would be the vertex form of the very same function that was given at the top of this question. And that's all.